Greetings to all my tech heads out there in the KevTechify Nation. And if you're new here, welcome. In this episode, we're going to look at Address Resolution Protocol, also known as ARP. We'll be discussing an ARP Overview, ARP Functions, removing entries from the ARP Table, ARP Tables on a network, and then we're going to look at some ARP issues, particularly the ARP Broadcast and ARP Spoofing. This episode is part of my series on Introduction to Networks for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. ARP is Address Resolution Protocol. Device uses ARP to determine the destination MAC address of a local device when it knows the IP version 4 address. ARP provides two basic functions: resolving an IP version 4 address to a MAC address, so we can get that destination NIC network interface on our network, and it maintains an ARP table, an address resolution protocol table of IP version 4 addresses or networks to map address settings. ARP functions. To send a frame here, a device will search its ARP table. So each device keeps its own address resolution protocol table for a destination IP version 4 address and its matching MAC address. If it's on the same network, it's going to search its ARP table to find that destination IP version 4 address. If the destination IP version 4 address is on a different network, that device is going to search the ARP table for the default gateway. That default gateway is the exit off of your network, so we got to send that information to the default gateway. Then the default gateway can route the data to its destination. If it locates an IP version 4 address, its corresponding MAC address is used as the destination MAC address in that layer 2 frame. If there's no ARP table entry found, so there in the address resolution protocol table, if there's no entry for that IP version 4 address, then the device starts a address resolution protocol request, an ARP request. We're going to go through an ARP request. We're going to look at how we go about finding a MAC address for that next network interface. It's a broadcast to everybody on our network. Hopefully one of those devices will respond with the correct MAC address. We are requesting information here at the link layer address. In this example, PCA is going to send an ARP request to PCC to get its MAC address, so that way we can send some data. PCA has an IP packet here. The source IP address 192.168.1.10 is the IP address here of PCA. Destination IP address 192.168.1.50, that is the IP address of PCC. What we have to find out here is, what is the destination MAC address? Because the source IP address and the destination IP address are on the same network, we don't have to go through another router onto a different network. Because the source IP address and destination IP address are on the same same network, the destination MAC address will be the MAC address of the destination IP address. PCA checks its ARP cache for the IP address, the destination IP address. Once again, 192.168.1.50. Because it's not in its ARP cache, the ARP cache doesn't show that IP address here. Because it's not in the ARP cache, we're going to go ahead and put that IP packet on hold. And then we're going to create an ARP request. The ARP request contains the target IP address 192.168.1.50, that's the IP address of PCC, and it contains the target MAC address. At this point in time, it is unknown. The ARP request, it's sent as a broadcast. If we look down here, the destination MAC address is all F's, it's all ones. That's a special MAC address, that's a broadcast. Any device on our local area network will hear this ARP request. PCA sends this ARP request to the switch. Because it is a broadcast, the switch will flood it out all ports except for the one it came in on. PCB receives the broadcast and processes it, and its ARP process takes the ARP request and compares its IP version 4 address against the target IP version 4 address, and it notices that it's not the same, and because they're not the same, it doesn't need to send an ARP reply. The router R1 also receives this ARP request. Its own ARP process examines its own IP address and compares it to the target IP address in the ARP request. R1 also realizes it's not its own IP address, so R1 does not have to send an ARP reply. Please note, routers do not forward ARP requests out their ports. So this ARP request stops at the router. It only stays on my network. It doesn't go to anybody else's network. PCC receives the ARP request. It compares its IP version 4 address to the target IP version 4 address. And it notices it is the intended target of the ARP request. The IP version 4 target address does match its own IP version 4 address. Because it matches, PCC will then have to send an ARP reply. I hope you're liking this episode on address resolution protocol. If you had the time, please leave a comment and let me know what you think about the address resolution protocol. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. An ARP reply is part of the process of finding out the MAC address of the next NIC, the next network interface. An ARP reply is a unicast response to an ARP request. So somebody made a request, let's respond back to it. It contains the information that is needed. It's sent to the requester's link layer address. It's sent to that MAC address, and it's the destination IP version 4 address that's on the same local area network. Looking at this example, PCA got in an ARP request. That ARP request, the target IP version 4 address matches PCC's IP version 4 address. Because it matches, PCC now needs to send an ARP reply. PCC will create that ARP reply. The ARP reply, the sender's IP address is the IP address of PCC because that's who is sending the ARP reply. And it also includes its own MAC address at this point in time. So the sender's MAC address of the ARP reply. This gets sent to PCA. ARP replies are sent as a unicast. The destination MAC address is of PCA. We can see that right here. PCA receives the ARP reply as a response to PCA ARP request and takes the reply information, the sender IP version 4 address and the sender MAC address, and adds that into PCA's ARP cache. We can see that added right in here, the information from our ARP reply. PCA can now take the original packet that was on hold. It has the information it needs to send that packet. It takes the information from the ARP cache and places it in the Ethernet header, the destination MAC address. PCA can now forward this Ethernet frame containing the IP packet to PCC. Now we're going to look at what if the destination IP address is not on your network. So we need to find the MAC address of the default gateway because that destination IP version 4 address is on a different local area network. PCA has an IP packet. The source IP address is its own IP address, but the destination IP address is not local to it. If it was local, it would start off with 192.168.1, but it doesn't start that way. That means we need to go through the router and go out to the internet. Remember, routers do not forward ARP requests, so we have to figure out how do we get there. What we have to do is we need to send it to our default gateway. Our default gateway is the exit off of our network. So the default gateway right here is this IP address. Data will come through here, go through the switch to this interface right here. This is our default gateway, connects into the router. The router then can send data on, because of the routing protocols, and reach its destination. When we look at this, what we have to figure out is this destination MAC address. Right here, this destination MAC address. Once again, that is the MAC address of our default gateway. How do we go about figuring that out? This is where that ARP request comes in. First thing PCA does is it checks its ARP cache. Is the destination IP address listed in the ARP cache? No, 10.1.1.10 is not listed in the ARP cache. Because it's not in the ARP cache table, we put that packet on hold. And then we create an ARP request. The ARP request has the target IP version 4 address of the router. It's right here. And right now, we still don't know what the target MAC address is, so that is unknown. The destination MAC address for the ARP request, that is a broadcast address. That is the special MAC address of all ones. Take all ones in binary, convert that into hexadecimal, that gives us all F. So that's the special address, that's the broadcast address for MAC addresses. PCA sends the ARP request to the switch. The switch then forwards it out all ports except for the port it received it in on. PCB receives the ARP request. PCB compares its own IP version 4 address to the target IP version 4 address. And notices those two IP addresses does not match. PCB is not the intended target. Because it's not the intended target, it stops processing the frame. PCC receives the ARP request, compares its IP version 4 address to the target IP version 4 address, and it is not the intended target either. Router 1 receives the ARP request, compares its IP version 4 address to the target IP version 4 address. And those two IP addresses, they do match. It is the target of the ARP request. Router R1 will issue an ARP reply in response. It will include its own MAC address, 000D. It'll also include its own IP version 4 address. The destination MAC address for the ARP reply is the unicast address. It'll be for PCA. PCA receives the ARP reply in response to its ARP request. When PCA receives the ARP reply, it sees the target IP version 4 address and the target MAC address, and then adds it to its ARP cache. Taking this information right here, putting it into PCA's ARP cache. It now has the information to forward the packet that is on hold. The destination MAC address is now going to be 000D, which is the MAC address of R1. That's its MAC address. And now PCA can forward the Ethernet frame onto R1, the default gateway. ARP table entries get removed after a period of time. It's up to the operating system and the iOS, but typically it happens between 15 and 45 seconds. If during that 15 to 45 seconds that ARP cache isn't used, it's going to delete that. And what happens if it needs it again? It repeats that entire ARP request process. Here we have two different ARP tables from different devices. The top one here is a Cisco router. Notice we have the host name here of R1. Type in the command show IP ARP, and that gives us the ARP table here. The second one is on a Windows PC. That command there is ARP -A, and then here is the ARP table on the PC. There are several issues with ARP, and it has to do with ARP broadcasting and ARP spoofing. ARP requests are received and processed by every device on the local area network. So if there's excessive amounts of ARP broadcast, it can degrade network performance some. Also, ARP replies are easily spoofed. If there is a bad actor, meaning like a hacker or something on your network, what they can do is an ARP poisoning attack. They can send bad information and confuse all the devices on your network. Enterprise level switches, they have mitigation techniques to fight against these ARP attacks. It was my pleasure to provide you with this wonderful episode on address resolution protocol. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There, you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks for the CCNA. In the bottom right is one of my favorite videos that I picked just for you. Thank you so much for watching this episode on my series on Introduction to Networks for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.